Hello friends, welcome to my channel Ravi Electronics for you. As a part of digital electronics, we are learning logic gates. We already covered NOT gate. In this section, we are going to learn about AND gate. AND gate is having two inputs, input 1, input 2 and single output. Input 1, input 2 and single output. Here the truth table for AND gate is if both inputs are high state, then the output is 1. Both inputs are high, then only you will get output as a high state. In remaining all the conditions, you will get logic low level. It means when both inputs are high, if the both inputs here you can understand here, if the both inputs are connected to logic 1 here, then only the electricity will flow here, the current will flow and the bulb will be on. If any one of the switch is open, either A or B, you will not get the current flow, so there will be no output here, so the LED will be off. So this is a simpler representation and understanding of AND gate. Our main criteria is we need to understand the AND gate with respect to transistor analogy. So if you draw the transistor analogy, it will look like this. So you'll be having two two transistors connected, two transistors connected, two NPN transistors. Transistor 1 output, that is the transistor 1 emitter is connected to the collector of another transistor. So this A and B is the inputs and here you are going to take the output. Now we are going to simulate this transistor analogy and we will see how this is going to work. This is the transistor analogy for AND gate. This is the transistor T1 and T2, both are NPN transistor. The transistors are connected in series, that is output of transistor 1 is connected to the collector of another transistor T2. Here I am having two inputs, input 1 and input 2 here. This is my input A and this is my input B, and I am having two switches here and this is my output. And we'll directly go to the understanding the logic gate here. So since both inputs are off state, there will be no current flow here. So I'm running the simulation. To run the simulation, since both inputs are logic 0 states, that means no input, that at that time there will be no output here. So it will be 0. Basically, there will be no current. These two transistors are in off state, so there will be no current flowing. So it is logic 0. Now if I make input A to supply, I am giving logic 1 here and logic 0 here. That time this transistor, even though you are making this two transistor is an on state, but it is not getting the ground path from this transistor. Because of that, since you are not getting ground path for this transistor, the transistor is in off state, so there will be no current flow. That time you will not get the output. The same case happen for the B also. Now I'm making B input to high state and this is logic 0 state. In this case also, you are not getting the current flow at the output. Now I'm making both inputs to high state. In this case only, since both transistors are in on state, you are getting the current flow through the LED. So this is on. This is how we can understand the AND gate with the transistor analogy. Now making off simulation off, and this is on again. This is how the transistor analogy for the AND gate. If I want to draw the AND gate symbol over here, so it will something look like this. So these are the inputs. The D shape, the D like this. This is the AND gate symbol over the transistor. Yeah. Next, I'm going to explain about the remaining gates, and our interest of doing this digital analysis. Once we complete this AND gates and all the remaining gates, XOR gate and XNOR gate, then we'll jump into the shift registers, how the shift register will works, how the binary, how the other flip-flops inside the shift registers works. So these things we are going to concentrate in the upcoming videos. Please subscribe to my channel. Thank you.